Okay, so we're now going to look at nuclear fusion. As I said to you in lesson, this promises to radically change your futures. It could be amazing for you. It says, what are the main issues with using it? So we're going to talk about the main issues. Because it's revision, I'm just going to do a tiny little bit on nuclear fusion. So this is when we fuse or join small nuclei. When this takes place, a small amount of mass is lost. And this is changed to energy according to E equals mc squared. So a small amount of mass makes lots and lots and lots of energy. So if I just come onto the side here, you can see how this works then. So I'm going to take hydrogen, take deuterium, and then this will fuse and we will make some helium, and then more of this will join. This is poor equation, you don't need to know the equation. We'll then make a bigger atom, so we're going to go to lithium, etc, etc, etc. And we need, the crucial part for this is we need a huge amount of energy because we need high temperatures and pressures. These nuclei are positive, so in order to get them to join, we've got to overcome repulsion. Okay, so we need a huge amount of energy to overcome repulsion. Okay, so we've got this idea, then we join a small nuclei to make larger atoms. Small amount of mass is lost during this, and this makes a little bit of energy according to Einstein's equations. And what we're doing is we're taking our smallest atoms, nuclei, and we're joining them. And when we join them, we'll make these larger atoms. And we need huge amounts of energy because of the positive, because there's repulsion from the nuclei. Okay, so I'm just going to come over to here. So what are the main issues with nuclear fusion as an energy source? Okay, so I'm going to get rid of all of this. And these little bits over here, because they were rubbishy notes anyway. And here we go. So it says, what are the main issues with nuclear fusion? So the first part is it requires lots of energy. And that's to overcome repulsion and enable us to join atoms. Okay, and put that into your own words. It requires lots of energy for us to overcome repulsion and join these atoms together. Because it requires, and therefore we need high temperatures and pressures to form a plasma. Okay, so that in itself, that's a bit of an issue. But the next part is to contain the plasma, to contain the reaction, we need to use very expensive magnets, and this is really difficult to control. So it is difficult to control the plasma with huge magnetic fields. And I said to you in class, it's pretty amazing. We've got the sort of highest temperatures we're creating on Earth right next, less than a metre away from the lowest temperatures needed for the magnets. And that is really difficult to control. And as a consequence, it just means that currently the reaction can't take place for very long. But we do have trial sites, mainly ITER down in France, where they're trying to get this working.